So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting.
We look at everything we know about life on Earth. And this is the kind of signature that we would see that was made by something biological.
Imagine the moment when a signal from over 140 million miles away arrives on Earth. A stream of data so unexpected that NASA's control room falls silent. The Perseverance rover, a six-wheeled explorer rolling across Jezero crater on Mars, has just detected something extraordinary. The numbers don't match any known geological pattern, and the images hint at something far more profound than simple rocks and dust. Scientists stare at their screens, their hearts pounding. Could this be the breakthrough that changes everything we thought we knew about our cosmic neighborhood? For decades, Mars has been the stage for humanity's greatest hopes and wildest dreams. We have sent orbiters, landers, and rovers, each one searching for the faintest whispers of life. We have traced the remnants of ancient riverbeds, mapped out dried-up deltas, and marveled at minerals that can only form in the presence of water. Each discovery has been a breadcrumb, leading us closer to an answer that has haunted scientists and dreamers alike. Are we alone? Until now, every clue was just that, a clue. But the latest findings are so compelling, so precise, that they might represent the clearest signs of life ever recorded on the red planet. Perseverance's sophisticated instruments, designed to detect organic molecules and analyze the chemical composition of Martian soil, recently returned readings that stunned even the most skeptical researchers. Within the layered rocks of Jezero crater, the rover uncovered complex carbon-based molecules arranged in patterns that, on Earth, are almost always associated with biological processes. These weren't just random chemical traces formed by chance. The molecular structures appeared organized, purposeful, hinting at processes that could once have been alive. To add to the intrigue, methane plumes, long considered a potential biosignature, were detected again, but this time their timing and concentration matched seasonal patterns similar to biological cycles on Earth. The discovery doesn't stop with molecules. High-resolution imagery revealed microtextures in the rocks that resemble stromatolites, layered structure created by microbial communities on our own planet billions of years ago. When images of these formations were first analyzed, a hush reportedly fell over NASA's geology team. The patterns were too regular, too reminiscent of fossils shaped by ancient life. One scientist was quoted as saying, "If this were on Earth, we wouldn't hesitate to call it biological." This moment feels like a culmination of centuries of curiosity. From early astronomers peering through telescopes, mistaking dark streaks for alien canals, to robotic pioneers like Viking and Curiosity testing soil for organic chemistry, the search for life on Mars has been relentless. Each mission brought us closer, but none delivered the unmistakable proof we craved. Now the pieces seem to be falling into place. Water once flowed freely on Mars, its atmosphere was thicker, its climate milder. Conditions for life, at least microbial life, could have been ideal billions of years ago. The evidence suggests Mars was not just habitable, it might have been inhabited. As news of Perseverance's findings spreads, debates erupt across scientific circles and social media alike. Skeptics urge caution, reminding the world of false alarms in the past. In 1996, a Martian meteorite called ALH 84001 sparked excitement with structures that looked like fossilized bacteria, only for alternative geological explanations to emerge later. But this time feels different. The data is more robust, the instruments more precise, and the evidence more varied. It isn't just one odd rock or one strange chemical signal, it's a convergence of multiple lines of evidence all pointing in the same direction. NASA has already begun planning follow-up investigations.
We found what we believe to be signs of microbial life on the Mars surface. And so we put it out to our scientific friends to pressure test it, to analyze it, and go, did we get this right? Do we think this is signs of ancient life on Mars?
Perseverance is caching samples of these promising rocks for a future mission that will bring them back to Earth. The upcoming Mars Sample Return mission, A collaboration with the European Space Agency could place these fragments in the hands of scientists by the early 2030s. With advanced laboratories on Earth, we can analyze the samples at resolutions impossible for a rover millions of miles away. If even a single microfossil or unambiguous biosignature is found, it would confirm that life once thrived on another world, a revelation that would redefine our understanding of biology, evolution, and our place in the universe. The implications extend far beyond science. Religions, philosophies, and cultures across the globe would grapple with the knowledge that Earth is not unique in nurturing life. Questions that were once the domain of science fiction. What does alien life look like? Could it have evolved intelligence? Might life exist elsewhere, perhaps even closer than we imagine, would become part of everyday conversations. Even the search for habitable exoplanets would gain renewed urgency, fueled by the realization that life can emerge in environments previously considered unlikely. Mars itself would transform in our imagination. It would no longer be just a desolate desert world, but a planet with a hidden history, a world that once pulsed with biology. The discovery could also reignite discussions about future human exploration and colonization. If life once existed on Mars, or perhaps still lingers deep underground, ethical questions arise. Should we protect it at all costs? Could our presence contaminate or destroy something precious and irreplaceable? In NASA's control room, the scientists are already moving cautiously, subjecting the data to rigorous peer review. Every possibility, from unusual mineral formations to unknown chemical reactions, will be tested before any formal announcement is made. The world waits, holding its breath for confirmation. But even now, the possibility alone has sparked a sense of wonder that transcends borders and beliefs. Think about what this means. If Mars, so close to us, so harsh and unforgiving, managed to host life at some point in its history, then life might not be rare at all. It could be the rule rather than the exception. Perhaps the universe is teeming with biology, from the frozen moons of Jupiter and Saturn to distant exoplanets circling alien suns. Every star in the night sky could be a sun to worlds alive with their own stories, waiting for someone, somewhere to listen. The discovery on Mars reminds us that exploration is not just about collecting data, it's about expanding the human spirit. Each rover, each telescope, each mission is a bridge between what we know and what we dare to dream. As Perseverance continues its lonely trek across Jezero crater, its tire tracks and the rust-colored dust are more than marks on a distant world. They are symbols of our relentless curiosity and our refusal to stop asking the biggest questions. And now, with the clearest signs of life on Mars shimmering on our screens, we stand on the edge of an answer that could change everything, forever.